We measure things all the time. How tall are you? How much coffee do you need? How far is it to the moon? Measurements help us understand the world around us. They help us build things, share information, and even bake a cake. Without measurements, life would be chaotic. Imagine a world without rulers, clocks, or scales. Metrology is the science of measurement. It's about making sure our measurements are accurate and reliable. Metrologists develop standards and techniques to ensure that a meter in France is the same length as a meter in the United States. This is important for science, engineering, trade, and many other fields. Accurate measurements are crucial for building anything. From skyscrapers to smartphones, engineers rely on precise measurements to ensure that parts fit together correctly. In medicine, accurate doses of medication are essential for effective treatment. Even in everyday life, we rely on measurements when we follow a recipe or check the air pressure in our tires. So the next time you measure something, take a moment to appreciate the importance of this fundamental human activity. It's something we often take for granted, but our world wouldn't be the same without it. Humans have been measuring things for a long time. Early civilizations used body parts like cubits, which are forearms, and digits, which are fingers, as units of measurement. The ancient Egyptians developed standardized units based on the length of a pharaoh's arm. These early systems were practical, but not very accurate. Over time, people developed more sophisticated measuring tools and techniques. The invention of the ruler, the compass, and the protractor revolutionized geometry and construction. The development of standardized units, like the meter and the kilogram, facilitated trade and scientific collaboration. The Renaissance saw a surge in scientific inquiry, which led to the development of even more precise measuring instruments. Galileo Galilei, the father of modern science, invented the hydrostatic balance for measuring the density of objects. His work paved the way for the scientific revolution and the development of modern metrology. Throughout history, the pursuit of more accurate measurements has driven technological innovation. From the astrolabe, used by ancient astronomers to measure the positions of stars, to the atomic clocks that keep our modern world synchronized, the quest for precision has shaped our understanding of the universe and our place within it. In 1631, a French mathematician named Pierre Vernier invented a device that would revolutionize precision measurement, the Vernier Caliper. This ingenious tool combined a standard ruler with a sliding scale, allowing for measurements with greater accuracy than ever before. Vernier's invention was based on a simple yet powerful concept. By adding a secondary scale with slightly different graduations to a standard ruler, he created a system where the alignment of the two scales could be used to determine measurements with remarkable precision. This innovation, known as the Vernier scale, has become a cornerstone of metrology. The Vernier caliper quickly gained popularity among scientists, engineers, and craftsmen. Its ability to provide accurate measurements in both inches and fractions of an inch made it an indispensable tool for a wide range of applications. From measuring the diameter of cannonballs to crafting intricate clockwork mechanisms, the Vernier caliper became an essential tool for anyone who needed to make precise measurements. Today, over 4 centuries after its invention, the Vernier caliper remains an essential tool in countless industries. Its simplicity, accuracy, and versatility make it a valuable asset for anyone from machinists and engineers to hobbyists and DIY enthusiasts. The Vernier caliper may seem like a simple tool, but its elegant design is a testament to the power of clever engineering. Understanding its basic components is key to appreciating its precision and versatility. Let's break down the anatomy of this ubiquitous measuring device. At its core, the Vernier caliper consists of 2 rulers. The main scale, typically located on the top or bottom of the tool, resembles a standard ruler with clearly marked graduations in inches or millimeters. This scale provides the initial coarse measurement. Attached to the main scale is the sliding jaw, which houses the Vernier scale. This secondary scale is the heart of the Vernier caliper's precision. It features a set of graduations that are slightly shorter or longer than those on the main scale. The difference in spacing between the two scales is what enables the caliper's fine measurements. The sliding jaw is equipped with two sets of jaws, the outer jaws for measuring external dimensions, and the inner jaws for measuring internal dimensions, like the diameter of a hole. These jaws can be moved along the main scale to take measurements. Finally, the caliper typically includes a depth gauge, a thin rod that extends from the back of the tool, perpendicular to the jaws. This feature allows for measuring the depth of holes, slots, or recesses. By combining these simple components, the Vernier caliper empowers users to make highly accurate measurements across a variety of applications. Its ability to measure both internal and external dimensions, along with depth, makes it a versatile tool for any workshop or laboratory. Section 5. Reading a Vernier caliper, a step-by-step guide. Reading a Vernier caliper might seem daunting at first, but with a little practice, it becomes second nature. Here's a step-by-step guide to help you master this essential skill. Step 1. Close the jaws. Before taking any measurement, ensure that the jaws of the caliper are fully closed. This sets the 0 point and ensures accuracy. Step 2. Position the object. Place the object to be measured between the jaws of the caliper, ensuring a snug fit. Step 3. Read the main scale. Look at the main scale and note the number where the 0 mark on the Vernier scale aligns with. This provides the whole number and the first decimal place of your measurement. Step 4. Find the coinciding line. Carefully examine the Vernier scale and identify the line that aligns perfectly with a line on the main scale. This is the key to achieving the caliper's precision. Step 5. Calculate the final measurement. Multiply the number of the coinciding line on the Vernier scale by the Vernier caliper's resolution, usually 0.01 inches or 0.02 millimeters. Add this value to the reading you obtained from the main scale. Example. In this example, the 0 mark on the Vernier scale falls between 2.3 inches and 2.4 inches on the main scale. The line on the Vernier scale that aligns perfectly with a line on the main scale is the fourth line. Since each line on the Vernier scale represents 0.01 inches, the final measurement is 2.3 plus 4 times 0.01, which equals 2.34 inches. With a little practice, you'll be reading a Vernier caliper like a pro in no time. Section 6. Vernier calipers in action. From machine shops to your garage. The Vernier caliper's versatility makes it an indispensable tool across a wide range of industries and applications. Let's explore how these precision instruments are used in various fields, manufacturing and machining. In manufacturing, precision is paramount. Vernier calipers are essential for quality control, ensuring that parts are manufactured to exact specifications. Machinists rely on them to measure the dimensions of machined parts, ensuring they meet the required tolerances for proper fit and function. Automotive industry. From engine blocks to brake rotors, precise measurements are critical in the automotive industry. Mechanics use Vernier calipers to diagnose engine problems, measure brake pad thickness, and ensure proper alignment of components. Construction and carpentry. Whether building a house or crafting furniture, accurate measurements are essential in construction. Carpenters use Vernier calipers to measure lumber dimensions, check the depth of cuts, and ensure precise alignment of structural elements. Science and engineering. In scientific research and engineering, Vernier calipers play a crucial role in data collection and analysis. They are used to measure the dimensions of specimens, test materials' properties, and conduct experiments that require precise measurements. Home use. Vernier calipers aren't just for professionals. They're also handy tools for DIY enthusiasts and hobbyists. Use them for home improvement projects, woodworking, jewelry making, or any task that requires accurate measurements. These are just a few examples of the countless applications of Vernier calipers. Their ability to provide accurate measurements in various units and their versatility in measuring different dimensions make them essential tools for professionals and hobbyists alike. Section 7. Beyond the basics, types of Vernier calipers. While the basic design of the Vernier caliper has remained remarkably consistent over the centuries, There are now several specialized types available, each tailored to specific applications and measurement needs. Let's explore some of the most common variations. Standard Vernier Caliper. This is the most common type, featuring the classic design with a main scale, a vernier scale, and both inner and outer jaws. It's suitable for a wide range of general-purpose measurement tasks. Digital Vernier Caliper. As technology advances, so do our measuring tools. Digital vernier calipers offer the convenience of a digital display, eliminating any potential for reading errors from the vernier scale. They often include additional features like data output capabilities and measurement conversions. Dial Vernier Caliper. This type features a circular dial that displays the measurement, offering a quick and easy-to-read alternative to the traditional vernier scale. It's particularly useful for repetitive measurements where speed is essential. Odd leg caliper. This specialized caliper has one leg that's specifically designed for scribing lines parallel to an edge. It's commonly used in woodworking and metalworking for marking out materials before cutting or machining. Depth Vernier Caliper. As the name suggests, this type is specifically designed for measuring depths. It typically features a longer depth gauge and may have a different jaw configuration, optimized for reaching into recesses and holes. Choosing the right type of vernier caliper depends on your specific needs and the intended applications. Consider the required measurement range, accuracy, and any special features that might be beneficial for your work. Section 8. Digital Calipers, the Modern Evolution. In today's digital age, it's no surprise that even the venerable Vernier caliper has gone digital. Digital calipers offer several advantages over their analog counterparts, making them increasingly popular in various fields. One of the most significant benefits of digital calipers is their ease of use. The digital display eliminates any ambiguity in reading the vernier scale, providing quick and unambiguous measurements. This is particularly helpful for beginners or when working with fine measurements where even a slight misinterpretation of the vernier scale can lead to errors. Digital calipers often come equipped with additional features that enhance their functionality. Many models offer measurement conversions between inches, millimeters, and fractions, simplifying the measurement process. Some calipers also feature data output capabilities, allowing users to record and analyze measurements electronically. Another advantage of digital calipers is their improved accuracy. While a skilled user can achieve impressive precision with a traditional vernier caliper, digital calipers eliminate the potential for human error in reading the scale. This makes them ideal for applications where even the slightest measurement discrepancy can have significant consequences. Despite the many advantages of digital calipers, traditional vernier calipers still hold their own in certain situations. They are often more affordable, more durable in harsh environments, and don't require batteries. The choice between digital and analog ultimately depends on the specific application, budget, and personal preferences. Section 9. The Enduring Legacy of the Vernier Caliper. For over 4 centuries, the Vernier caliper has remained an essential tool for anyone who needs to make precise measurements. From its humble beginnings in 17th century France to its modern-day incarnations, this ingenious device has played a pivotal role in countless scientific discoveries, engineering marvels, and everyday tasks. The Vernier caliper's enduring legacy is a testament to the power of simple yet elegant design. By combining 2 scales with slightly different graduations, Pierre Vernier unlocked a new level of precision measurement, empowering generations of scientists, engineers, and craftsmen. Today, even as technology advances at an unprecedented pace, the Vernier caliper continues to be an indispensable tool in countless industries. Its simplicity, accuracy, and versatility make it a valuable asset for anyone from seasoned professionals to curious hobbyists. So the next time you encounter a Vernier caliper, take a moment to appreciate its rich history and the ingenuity of its design. This unassuming tool represents a triumph of human ingenuity, a testament to our enduring quest to measure, understand, and shape the world around us. The Vernier caliper is more than just a measuring tool, it's a symbol of human curiosity, our relentless pursuit of precision, and our ability to create tools that extend our capabilities and deepen our understanding of the universe.